with Python. Just be aware that I've designed this course for beginners, so if you have some programming experience, check out my other Python course for developers. You can see the link on the top right corner of this video. So, Python is the world's fastest growing and most popular programming language, not just amongst software developers, but also amongst mathematicians, data analysts, scientists, accountants, network engineers, and even kids. In fact, it's the ideal programming language to learn first. But what makes Python so special? Here are 6 reasons. With Python, you can solve complex problems in less time with fewer lines of code than many other languages. That's why huge companies like Google, Spotify, Dropbox, and Facebook have embraced this beautiful and powerful language. Here's an example. Let's say we want to extract the first 3 characters of the text "Hello World." This is the code we would have to write in C#. This is how we would do this in JavaScript. And here's how we would do it in Python. See how clean and simple the language is? And that's just the beginning. Python is a multi-purpose language, and you can use it for a wide range of jobs such as data analysis, AI and machine learning, writing automation scripts, building web, mobile, and desktop applications, as well as software testing or even hacking. So if you want a high-paying, long-lasting career in any of these areas, especially AI and machine learning, Python is the language to put those opportunities at your fingertips. In fact, according to Indeed.com, the average salary of a Python developer in the US was over $115,000 in March 2018. And here are 4 more reasons that make Python the most desirable language. Python is a high-level language, so you don't have to worry about complex tasks such as memory management as you do in C++. It's cross-platform, which means you can build and run Python apps on Windows, Mac, and Linux. It has a huge community, so whenever you get stuck, there is someone out there to help. And it has a large ecosystem of libraries, frameworks, and tools. Whatever you want to do, it is likely that someone else has done it before, because Python has been around for over 20 years. There are 2 versions of Python out there. Python 2, which is the legacy version of Python and is going to be supported until year 2020. And Python 3, which is Python for the future. In this course, you're going to learn Python 3. Hi, my name is Mosh Hamedani, and I'm going to be your instructor in this course. I'm a software engineer with 18 years of experience, and I have taught way over 1 million people how to code or how to become top professional software engineers. To learn more about me and my courses, head over to codewithmosh.com. All right, now let's get started. All right, now we're ready to download and install Python. The first thing I want you to do is to open up your browser and head over to python.org. On this page, under the downloads, you can see the latest version of Python. Currently, the latest version is 3.7. Chances are in the future, when you're watching this video, there is a newer version available. Don't worry, all the materials in this course will continue to apply with the future versions of Python. So go ahead and download Python and then run it. If you're on Windows, you're going to see this checkbox here, add Python to path. This is very important. Make sure to tick it. Otherwise, you're not going to be able to follow the course. So now go ahead and install it. Now let's verify that we have installed Python properly. If you're on Windows, here in this search bar, type CMD, which is short for command prompt. Now here in command prompt, type Python. You can see we have successfully installed Python version 3.7. Now to exit, press Ctrl Z and then enter. Done. If you're on Mac, press Command and space. This opens up the Spotlight search. So here type terminal. Terminal on Mac is like command prompt on Windows. Now Mac and Linux by default come with an older version of Python, that is version 2. So if you type Python, you can see Python 2 here. That's not what we want. So press Ctrl D to exit and then run Python 3. And this verifies that we have successfully installed Python 3.7. So this environment you see here is what we call Python Interpreter, which is basically a program that executes Python code. We can type our Python code in a file and give it to this interpreter, or we can type our code directly here in this interactive shell. So here we can write an expression like 2 plus 2. In programming, an expression is a piece of code that produces a value. So here, when we add 2 plus 2, we get a value. That is why we refer to this piece of code as an expression. So enter, we get 4. Let's try a different kind of expression. Let's see if 2 is greater than 1. We get true, which is an example of a Boolean value. You're going to learn about these Boolean values in the next section. Now, what if we type 2 is greater than 5? Enter, we get false. So in programming, we have true and false, which are similar to yes and no in English. Now, what if we type 2 is greater than, but we don't add a second value here? Just press enter. We get a syntax error. In programming, syntax means grammar. So just like we have the concept of grammar in the languages that we speak, we have the exact same concept in programming. If we write a sentence that is not grammatically correct, chances are some people may not understand that sentence. So in this example, we have this expression which is incomplete. It doesn't have the right grammar or syntax. That is why Python interpreter is complaining by returning an error. So this interactive shell is a great way to quickly experiment with a bit of Python code. But that's not how we build real-world applications. To do that, we need a code editor. And that's what I'm going to show you in the next lecture. When it comes to typing Python code, you have two options. You can use a code editor or an IDE, which is short for Integrated Development Environment. An IDE is basically a code editor with some fancy features like auto-completion, which means as you type code, this feature helps you complete your code. So you don't have to type every character by hand. It's a productivity boosting feature. It also gives you additional features like debugging, which means finding and fixing bugs in your programs, testing, and so on. For both code editors and IDEs, there's so many options out there. The most popular code editors are VSCode, Atom, and Sublime. You can use the code editor that you prefer. In terms of the IDEs, again, there are so many options out there. The most popular one is PyCharm. In this course, I'm going to use VS Code or Visual Studio Code because that's my favorite code editor. Later in the course, I will show you how to install a plugin or an extension that will convert VS Code to a powerful IDE. So before going any further, head over to code.visualstudio.com and download the latest version of VS Code. Now with VS Code open, on the top, from the File menu, go to Open, and somewhere on your disk, create a new folder. Let's call this folder Hello World. And then open it. Beautiful. Now click this icon on the top. This opens up the Explorer panel. In this panel, you can see all the files and folders in your project. So let's add a new file and call that app.py. So all our Python files should have the py extension. Press enter. Now let's close this and type a bit of Python code. In this lecture, we're going to use one of the built-in functions in Python called print. So in Python, we have a lot of built-in functions for performing various kinds of tasks. For example, as a metaphor, think of the remote control of your TV. On this remote control, you have a bunch of functions like turn on, turn off, change the channel, change the volume, and so on. These are the built-in functions in your TV. We have the same concept in Python and many other programming languages. So one of these built-in functions that comes with Python is print. And we can use this to print something on the screen. Now, whenever you want to use a function, you should open and close parentheses. In programming, we say we're calling the print function. Calling a function means executing it. Now let's display the hello world message on the screen. Whenever you want to work with text, you should put your text in between quotes, either double quotes or single quotes. Now I'm going to go with double quotes and add hello world, and then put a happy Persian cat here. Beautiful. Save the changes with Command and S on Mac or Control and S on Windows. Now to execute this code, we need to go back to Command Prompt on Windows or Terminal on Mac. But the good news is that we don't have to switch programs. Here in VSCode, we have an integrated terminal. So press Control and backtick. That is the key before number 1 on your keyboard. That is just below the escape button. So this is our integrated terminal. Now if you're on Windows, type Python. If you're on Mac or Linux, type Python 3. And next to that, add the name of our file. That is app.py. And here's our hello world message in the terminal. Beautiful. Now let's take this to the next level and make it a little bit more interesting. Let's close this terminal window by pressing Control and backtick and add a second line of code. So one more time, print. This time, let's add quotes with a star in between them. Now let's say we want to repeat this star 10 times. So here we can multiply this by 10, save the changes, open up the terminal, and run our program. And you can see this star is repeated 10 times. So as you see, the instructions in our program are executed from top to bottom in order. In the next lecture, I'm going to show you how to convert this VS Code to a powerful IDE for building Python applications. In this lecture, I'm going to show you how to convert VS Code to a powerful IDE by using an extension called Python. With this extension or plugin, we get a number of features such as linting, which basically means analyzing our code for potential errors. We also get debugging, which involves finding and fixing errors. We'll look at this later in the course. We also get auto-completion, which basically helps us write code faster, so we don't have to type every character. We get code formatting, which is all about making our code clean and readable, just like how we format our articles, newspapers, books to make them clean and readable. We get unit testing, which involves writing a bunch of tests for our code. We can run these tests in an automated fashion to make sure our code is behaving correctly. And finally, we get code snippets, which are reusable code blocks that we can quickly generate, so we don't have to type them all by hand. Now, don't worry about memorizing any of these. As we go through the course, you're going to learn about these features. Now, here in VS Code, on the left side, click this icon. This opens the Extensions tab. So these are the extensions that we can install in VS Code to bring in additional functionality. Here under the Recommended tab, you can see the Python extension. If you don't see this, simply type Python here on the top. And here's the extension. So go ahead and install this. And then you will have to reload VS Code. Now here on the bottom right corner, you can see this message, linter pylint is not installed. So as I told you before, linting is about finding potential errors in our code. Linter is a program or a tool that analyzes our code and finds these potential problems. Now for Python, there are several linters out there. Pylint is one of the most popular ones that this Python extension uses by default. So we need to go ahead and install Pylint as well. Now to do this, first we need to change our Python environment. So if you look here on the bottom left corner, you can see the current Python that is used in VS Code, that is Python 2.6.9 on my machine. Chances are you see a different version here. So click here, and in this list, make sure to select Python 3.7. So this changes our Python environment to Python 3.7, and then we can install Pylint by clicking this button. Okay, Pylint is installed. Beautiful. In the next lecture, I will show you how linting works. In this lecture, I'm going to show you linting in action. So let's start by writing some invalid code like this. Print, space, with no parentheses, and then hello world. Earlier I told you that print is a built-in function, and whenever you want to use or call a function, you should always use parentheses. Now, to be more precise, this is actually valid Python 2 code, but because we're using Python 3 here, this is invalid code from Python 3's point of view. So now when I save the changes, you can see this red underline here. Let's hover our mouse over this underline. You can see this tooltip. It's coming from Python, and here's the error message. Missing parentheses in call to print. Did you mean print with parentheses? So this is the benefit of linting. As you're writing code, you can see potential problems in your code. You don't have to wait to run your program to see these errors. So now, if we put parentheses here and save the changes, you can see that red underline is gone. Let's look at another error. Let's type 2 plus and then save the changes. Earlier, we ran this code in Python Interpreter's interactive shell. There, we got a syntax or grammar error. So if you hover your mouse here one more time, you can see Pylint is telling us that this is invalid syntax or invalid grammar. It's like an incomplete sentence. So this is linting in action. Now let me show you a couple useful shortcuts here. On the top, look at the view menu. Here we have this problems menu. Look at the shortcut. On Mac, it's Shift, Command, and M. On Windows, it's probably Shift, Control, M. So as you're working with VSCode, try to memorize these shortcuts because they really help you write code faster. Now let's take a look at this problems panel. So this problems panel lists all the issues in your code in one place. So if you have an application with multiple files, this is really useful because some of those files may not currently be open. So this linter, Pylint, will analyze all your files, and if it finds any issues, it will list them here in the problems panel. Now you can also put this on the right side of the screen. So let's put it here. So as you write code, these problems will appear here. Now let's fix this issue. So I'm going to add 3 here, save the changes, and you can see the problem disappeared. And one last thing before we finish this lecture. Once again on the top, let's go to the view menu. The first item is command palette. This is a very important feature in VS Code. Once again, look at the shortcut that is Shift, Command, and P on Mac or Shift, Control, P on Windows. With this command palette, you can execute various commands in VS Code. If you type lint here, you can see all commands related to linting. As you can see, all these commands are prefixed with Python because these commands come with the Python extension that we installed earlier. So these are additional features available to us in VS Code. The first command here is select linter. In this list, you can see various linters available for Pylint. So as you're reading tutorials or talking to other people, you will hear about linters such as Flake 8, MyPy, Pep8, and so on. Different developers prefer different linters. I personally prefer Pylint. That is the most popular one, and that is the default linter set in the Python extension of VS Code. If you're adventurous, you can try using other linters on your own. The difference between these linters is in how they find and report errors. Some error messages are more meaningful or more friendly. The others are more ambiguous. So that's all about linting. In the next lecture, we'll talk about formatting code. In Python community, we have a bunch of documents called Python Enhancement Proposals or PEPs. Here on Google, if you search for Python PEPs, you can see the list of all these PEPs under python.org/dev/PEPs. Let's have a quick look here. So here are the PEPs. You can see each PEP has a number and a title. The one that is very popular amongst Python developers is Pep8, which is a style guide for Python code. A style guide is basically a document that defines a bunch of rules for formatting and styling our code. If you follow these conventions, the code that you write will end up being consistent with other people's code. Now, if you have time, you can go ahead and read this PEP 8 documentation. But if not, don't worry, because throughout this course, I'm going to explain the key things in PEP 8. In this lecture, I'm going to show you a tool that helps you automatically format your code according to PEP 8. So back in VS Code, let's write some Python code. X equals 1. Here I'm declaring a variable and setting it to 1. If you're not familiar with variables, don't worry. In the next section, you're going to learn about them. So according to PEP 8, this code is considered ugly because by convention, we should add a space around this equal sign or the assignment operator. Now, since you're starting out with Python, you probably don't know these rules. So let me show you a tool that helps you automatically format your code. Let's revert this back to its original state. Now we need to go back to the command palette. Remember? So it's right here under View, and the shortcut is Shift, Command, and P. Here, if you search for format, you can see this command, format document. The first time you execute this command, you're going to see this message here. Formatter AutoPEP 8 is not installed. So there are a bunch of tools for formatting Python code. The most popular one is AutoPEP 8. And this is the tool that this Python extension we installed uses to format our code. So let's go ahead and install this. Good. Now one more time, let's open up the command palette and execute format document. See, this tool automatically formats our code. Beautiful. Let's take a look at another example. I'm going to declare another variable, y, and set it to 2, and a variable with a long name, like unit underline price, and set this to 3. Now, some developers have this habit of formatting their variable declarations like this. So they put all these equal signs in the same column. According to PEP 8, this is considered ugly. So once again, let's format our code. That is better. Beautiful. Now let me show you a trick. Opening up this command palette and searching for format document every time is a little bit time consuming. So I'm going to show you how to have your file automatically formatted as soon as you save the changes. On the top, let's go to the code menu, preferences, and settings. Here in the search box, search for format on save. So we have this option, editor, format on save. Take this. Now back to app.py. I'm going to change the formatting of these lines, make them really ugly. Now, as soon as I save the changes, you can see my code is reformatted. Beautiful. So you have learned that in order to run this Python program, we'll have to open up the terminal window and run Python on Windows or Python 3 on Mac, and then app.py. This is a little bit tedious. So let me show you a shortcut. Once again, let's go to the extensions panel. Here, search for code runner. There are multiple code runners out there. The one that I'm talking about is this one with the yellow icon. So go ahead and install this and then reload VS Code. Now, instead of opening up the terminal and manually typing Python app.py, all you have to do is to press Ctrl, Alt, and N. You can see the output here. Beautiful. Just be aware that if you make any changes, you will have to save the changes before using this shortcut. Otherwise, you're going to see the old result. Now, there is a tiny problem here. So you can see this is the command that is executed to run this Python program. So by default, this command is using python-u, and here is the name of our file. If you're on Windows, that's perfectly fine. But if you're on Mac, you know that Python refers to Python 2. Here we want to change this to Python 3. This is very easy. Once again, on the top, under the code menu, let's go to Preferences, Settings. And then here, under this ... go to Open Settings.json. Now here in the search bar, type code-runner.executor map. So these are the default settings used by this code runner extension. You can see this extension supports executing code in a lot of languages like JavaScript, Java, and so on. Now, if you scroll down, here we can see Python, and in front of that, you can see the command that is used to execute Python code. We need to change this. However, we cannot change the default settings. We should change the user settings. So on the right side, after the last setting, type a comma, and then in quotes, type code-runner.executor map, and then press enter. This will automatically copy all the settings on the left side to the right side. Now we can easily change one of these. So here's Python. Let's change the command to Python 3. You only have to do this if you're on Mac. And by the way, sorry if I have mentioned Windows and Mac a few times throughout this course. That's pretty much it. We're not going to differentiate between Windows and Mac in the future. So save the changes and we're done. So I've got a few questions for you because I want to see if you have been really paying attention to this video or not. You better have. So here's the first question. For each question, I want you to pause the video, think about the answer for a few seconds. When you're ready, continue watching. So here's the first question. What is an expression? An expression is a piece of code that produces a value. Here's an example of an expression. What do you think is the value of this expression? Well, here we have this string. We're multiplying this by 3. So the result will be a string of 3 asterisks, like this. Here's another question. What is a syntax error? A syntax error is a kind of error that is due to bad syntax or bad grammar in the code. And finally, the last question. What does a linter do? A linter is a tool that checks our code for potential errors, mostly in the category of syntactical errors. So if you have grammatical issues in our code, the linter will tell us before running our program. Okay, that's it for now. If you like more quizzes and programming exercises, look at the link below this video. And if you have enjoyed this video, I hope you have, please support me by giving a thumbs up. Please like this video and share it with others. In the next section, we're going to look at the fundamentals of Python. Well, hello, Mosh here. Thank you for watching my Python tutorial. I wanted to let you know that this tutorial is the first 2 hours of my complete Python course, where you will learn how to use Python in real-world scenarios such as data analysis and visualization, automating repetitive, boring tasks that involve working with files and folders, spreadsheets, PDFs, data compression, sending emails, web crawling, consuming APIs like Yelp to get information about businesses, and much, much more. This course comes with a 30-day, no questions asked, money-back guarantee and a certificate of completion. If you're interested, click the link below this video to access the course. Let's start this section by a discussion of variables, which are one of the core concepts in programming. We use variables to store data in computer's memory. Here are a few examples. I'm going to define a variable called students_count and setting it to 1,000. When we run this program, Python interpreter will allocate some memory and store this number 1,000 in that memory space. Then it will have this variable reference that memory location. So this variable is just like a label for that memory location. We can use this variable or this label anywhere in our program to get access to that memory location and the data stored there. So now if we print students count and run our program, we will get the number 1,000. So this is the basic of variables. Now, what kind of data can we store in computer's memory? Well, we have several different kinds of data. In this section, we're going to look at the built-in primitive types in Python. Primitive types can be numbers, booleans, and strings. Let me show you. So here we have a whole number. We refer to this as an integer in programming. We can also have numbers with a decimal point. Let's take a look. So rating, we set this to 4.99. This is what we call a float or a floating point number. And this terminology is not specific to Python. In the future, when you learn a new programming language, you're going to hear these terms again. Now let's take a look at an example of a Boolean. Is published, we set this to true or false. These are examples of Boolean values in programming. So Boolean values can either be true or false, and these are exactly like yes and no in English. Later in the course, you will learn that we'll use these Boolean values to make decisions in our programs. For example, if the user is an admin user, perhaps we want to give them extra permissions. So these are the Boolean values. Now take into account that Python is a case-sensitive language, which means lowercase and uppercase characters have different meanings. So Boolean values should always start with a capital letter, like what you see here. If we type false or false, these are not accepted Boolean values in Python. Only what you see here is a valid Boolean value. So false or true. And finally, let's take a look at an example of a string. So course underline name, we set this to a string like Python programming. So a string, as I told you before, is like text. Whenever you want to work with text in your programs, you need to surround your text with quotes. So these are the basics of variables. So these are the variables from the last lecture. Now I've got a question for you. There are 4 things that I have consistently used in this program. Can you spot them? If you want, you can pause the video, think about this for a few seconds, and then continue watching. So here are those 4 things. The first thing is that all my variable names are descriptive and meaningful. So students count represents the number of students for a course, or course name clearly explains that this variable holds the name of a course. One of the issues that I see a lot amongst beginner programmers is that they use mystical names for their variables. Something like this, CN as in short for course name. When someone else reads this code, they have no idea what CN stands for. Or they use variable names like C1. When I look at that code, I wonder, where is C2? And what is the difference between C1 and C2? So these variable names are very mystical. That's a bad practice. Make sure your variable names are always descriptive and meaningful because this makes your code more maintainable. Now, there are times that you can use short variable names like X, Y, Z if you're dealing with things like coordinates. So that's an exception. Now, the second thing that I have consistently used in this code is that I have used lowercase letters to name my variables. So here we don't have course name all in capital or in title case. All letters are lowercase, right? Let's delete these. The third thing that I've consistently used here is that I have used an underscore to separate multiple words. And I've done this to make my variable names more readable. Because in Python, we cannot have a space in variable names, so we cannot have course name. And if you put these 2 words together, it's a little bit hard to read. That's why we use an underscore. And the fourth thing that I have used consistently here is that I have put a space around this equal sign. Again, that's one of the issues I see a lot amongst beginners. They write code like this. This is a little bit ugly. This is what we call dirty code. Dirty, stinky, smelly. You should write code that is clean and beautiful, so other people can read it like a story, like a newspaper article. It should be formatted properly. And that's why we have PEP 8 in Python. Now, the good thing is if you forget these rules, when you save the changes, auto PEP 8 kicks in and it automatically reformats your code. But that aside, you should always give yourself the habit of writing clean code without relying too much on the tooling. So these are all the best practices about naming your variables. Next, we're going to look at strings in more detail. So here we have this course variable set to Python programming. As I told you before, whenever you work with text, you should surround your text with quotes. You can either use double quotes or single quotes. That's more of a personal preference, but quite often we use double quotes. We also have triple quotes, and we use them to format a long string. For example, if you have, let's say, a variable message, that is the message we want to include in the body of an email, you can use triple quotes to format it like this. Hi, John. This is Mosh from codewithmosh.com, blah, blah, blah. So that's when we use triple quotes. Now, we don't need this in this lecture, so delete. Let me show you a few useful things you can do with strings. First of all, we have this built-in function in Python for getting the length of strings. What is a function? A function is basically a reusable piece of code that carries out a task. As a metaphor, think of the remote control of your TV. On this remote control, you have buttons for different functions, like turn on, turn off, change the channel, and so on. These are the built-in functions in your TV. In Python and many other programming languages, we have the exact same concept. So we have functions that are built into the language and the platform. You can reuse these functions to perform various tasks. So here we can use the built-in len function to get the length of a string, which means the number of characters in that string. Now, whenever you want to use a function, you should use parentheses. Now we say we're calling this function, which basically means we're using this function. Now, some functions take additional data, which we refer to as arguments. These arguments are inputs to these functions. So this len function takes an input or an argument. Here we pass our course variable, and this will return the number of characters in this string. So let's print that and see what we get. Run the program. We get 18 because we have 18 characters here. Let's look at another example. If you want to get access to a specific character in this string, you use the square bracket notation. So here we add course, square brackets. To get the first character, you use the index 0. So in Python, like many other languages, strings are 0 indexed, which means the index of the first character or the first element is 0. So now when we print this, we'll get P, okay? Now you can also use a negative index, like -1. What does that mean? Well, if 0 represents the first character here, what do you think -1 represents? That takes us back to the end of the string. So that returns the first character from the end of the string. Let's run this program. You will see we'll get G. There you go. Using a similar syntax, you can slice strings. Let me show you. So I'm going to duplicate this line and remove -1. Now let's say we want to extract the first 3 characters in this string. So here we need 2 indexes. The start index, colon, the end index. So this will return a new string that contains the first 3 characters in this course variable. That will be P, Y, and T. So the index of these characters are 0, 1, and 2. So that means the character at the end index is not included, okay? Let's run the program and make sure we get the right result. There you go, PYT. Now, what if we don't include the end index? What do you think we're going to get? It's common sense. We start from index 0 and go all the way to the end of the string. So this will return a new string that is exactly the same as the original string. Let's take a look. So we get Python programming. Now, what if we don't include the start index, but include the end index? What do you think we're going to get? Once again, it's common sense. So by default, Python will put 0 here. So it will start from the beginning of the string. So when I run this program, we should get PYT one more time. There you go. And finally, as the last example, if we don't include the start and the end index, this will return a copy of the original string. Let's look at this. So we get Python programming. Now, you don't have to memorize any of these. Just remember, we use the len function to get the length of a string. We use bracket notation to get access to a specific element or a specific character. And we use this notation to slice a string. So we have this string here, Python programming. Now, let's say we want to put a double quote in the middle of this string. There is a problem here. Python interpreter sees this second string as the end of the string. So the rest of the code is meaningless and invalid. How do we solve this problem? Well, there are two ways. One way is to use single quotes for our string, and then we can use a double quote in the middle of the string. But what if for whatever reason, perhaps for being consistent in our code, we decided to use double quotes? How can we add another double quote in the middle of this string? Well, we can prefix this with a backslash. Backslash in Python strings is a special character. We have a jargon for that called escape character. We use it to escape the character after. Let me show you what I mean. So let's print this course and run this program. What's going on here? We don't have the backslash because we use that to escape this double quote and basically display it here. So backslash is an escape character and backslash double quote is an escape sequence. In Python strings, we have a few other escape sequences that you should be aware of. Let me show you. So in Python, we use a hash sign to indicate a comment. A comment is like additional note that we add to our program. It's not executed by Python interpreter, okay? So here are the escape sequences. You have seen backslash double quote. We also have backslash single quote. So we can use that to add a single quote here. Let's run the program. Here it is, beautiful. We also have double backslash. So if you want to include a backslash in your strings, you should prefix it with another backslash. Let me show you. So when we run this, we get Python 1 backslash programming. And finally, we have backslash n, which is short for new line. So now if I add a backslash n here, see what we get. We get a new line after Python, so programming will end up on the second line. So these are the escape sequences in Python. Here we have two variables, first and last. Let's say we want to print my full name on the console. So we can define another variable, full, set it to first, then concatenate it with a space, and one more time concatenate it with last. Now when we print full, we get my full name on the console. Beautiful. Now this approach of using concatenation to build a string is okay, but there is a better and newer approach. We can use formatted strings. So here we can set full to this string and prefix it with an f, which can be lowercase or uppercase. This formatted string doesn't have a constant value like these two strings here. It's actually an expression that will be evaluated at runtime. So here we want to add our first name. We use curly braces to print the value of the first variable. After that, we add a space, and then we add curly braces one more time to print the last name. So at runtime, this expression will be evaluated. What we have in between curly braces will be replaced at runtime. Now let's run this program one more time. We get the exact same result. Just be aware that you can put any valid expressions in between curly braces. So earlier you learned about the built-in len function. We can call len here to get the length of this string. Let's run this program one more time, so we get 4. We can also replace last with an expression like this, 2 plus 2. Let's run this program. We get 4 and 4. So when using formatted strings, you can put any valid expressions in between curly braces. In this lecture, we're going to look at a few useful functions available to work with strings. So earlier you learned about this built-in len function. This function is general purpose, so it's not limited to strings. Later, I will show you how to use this function with other kind of objects. But in Python, we have quite a few functions that are specific to strings. Let me show you. So here, if we type course dot, see, all these are functions available on strings. Now, in precise terms, we refer to these functions as methods. This is a term in object-oriented programming that you will learn about later in the course. For now, what I want you to take away is that everything in Python is an object, and objects have functions we call methods that we can access using the dot notation. So here, course is an object. We use the dot notation to access its functions, or more accurately, methods. Let's take a look at a few of these methods. We have upper to convert a string to uppercase. Now let's print this and run the program. Here's what we get. Beautiful. Now note that the methods that you call here return a new string, so the original string is not affected. Let me show you. So print course, run the program one more time. Look, this is our original string, right? So course.upper returns a new string, a new value. We can store it in a variable like course, underline capital, like this. Now, to keep this demo simple and consistent, I'm going to revert this back and use a print statement. We also have the lower method to convert a string to lowercase. We also have title, which will capitalize the first letter of every word. So if our string was like this, when we call the title method, we get Python programming as you see here. Okay. Another useful method is strip, and we use it to trim any white space at the beginning or end of a string. This is particularly useful when we receive input from the user. Let me show you. So let's imagine the user entered a couple of white spaces at the beginning of the string. When we call course.strip, those white spaces will be removed. Take a look. So note that in the first 3 examples, we have those white spaces, but in the last one, it is removed. So a strip removes the white space from both the beginning and end of a string. We also have lstrip, which is short for left strip, and rstrip, which is short for right strip. So it will remove the white space from the end of a string. If you want to get the index of a character or a sequence of characters in your string, you should use the find method. Let me show you. So course.find. So as an argument, here we pass another string. We can pass a character or a series of characters. Let's find the index of pro. Run the program. So the index of pro is 9. So if you start from 0 here all the way to 9, this is the index of pro. Okay? Now, as I told you before, Python is a case-sensitive language. So if I pass a capital P here, obviously we don't have these exact characters in our string. So let's see what we get. We get -1. That means this string was not found in the original string. Another useful method is replace. So we call replace. With this, we can replace a character or a sequence of characters with something else. So let's say we want to replace all lowercase p's with j. With this, we get Python gyrogramming, whatever that means. And finally, if you want to check for the existence of a character or a sequence of characters in your string, you can use the in operator. Let me show you. So print, we write an expression like this, pro in course. So this is an expression, As I told you before, an expression is a piece of code that produces a value. So this expression checks to see if we have pro in course. The difference between this expression and calling the find method is that the find method returns the index of these characters in our string, whereas this expression returns a boolean, so it's a true or false. Let me show you. So run the program, we get the boolean true. And finally, we have the not operator, and we use that to see if our string does not contain a character or a sequence of characters. So let's change this to Swift, not in course. When this expression is evaluated, what do you think we're going to get? Well, we don't have Swift in this string, so not in will return true. Let's take a look. There you go. So these are the useful string methods. Next, we'll look at numbers. In Python, we have three types of numbers. Two of these you have already seen before. They are integers and floats. We also have complex numbers. So complex numbers in math are in the form a plus bi, where I is the imaginary number. Now, if you're not familiar with this concept, don't worry. This is something that is used a lot in mathematics and electrical engineering. If you want to use Python to build web applications, you're never going to use complex numbers. But let me quickly show you the syntax for representing complex numbers. Instead of I, we use j. So here is an example, 1 plus 2j. So x now is a complex number. And by the way, as I told you before, this is just a comment or an additional note in our program. When we run this program, anything after this hash sign will be ignored. So these are the three types of numbers we have in Python. For all these types of numbers, we have the standard arithmetic operations that we have in math. Let me show you. So we have addition, subtraction, multiplication, division, but we actually have two different types of divisions. Let me show you. First, let's run this program. So with this division operator, which is a slash, we get a floating point number. If you want an integer, you use double slashes. Let me show you. So double slash, run the program, we get 3, okay? We also have modulus, which is the remainder of a division. And finally, exponent, which is left to the power of right. So 10 to the power of 3 will be 1,000. These are the standard arithmetic operators. Now, for all these operators, we have a special operator called augmented assignment operator. Let me show you. So let's imagine we have x set to 10. We want to increment x by, let's say, 3. We can write an expression like this, x equals x plus 3, or we can use an augmented assignment operator. That is a little bit shorter. So we write x plus equal 3. These two statements are exactly the same. Now here I'm using addition as an example. You can use any of these operators here. Next, I'm going to show you some useful functions to work with numbers. In this lecture, we're going to look at a few useful functions to work with numbers. So we have this built-in function round for rounding a number. So if we pass 2.9 here and print the result, we will get 3. We have another useful built-in function called ABS, which returns the absolute value of a number. So if we pass negative 2.9 here, we'll get positive 2.9. Technically, we have only a handful of built-in functions to work with numbers. If you want to write a program that involves complex mathematical calculations, you need to use the math module. A module is like a separate file with some Python code. So in Python, we have this math module, which includes lots of mathematical functions for working with numbers. but we need to import this module so we can use it. On the top, we type import math. Now math in this program is an object, so we can use the dot notation to see all the functions, or more accurately, all the methods available in this object. As an example, we have math.ceil for getting the ceiling of a number. So if we pass 2.2 here and run this program, we get 3. Now in this math module, we have lots of functions. Let me show you how to find the complete list. Here on Google, search for Python 3. Make sure to add the version number, math module. On this page, you can see all the functions in the math module. So in this lecture, we looked at math.ceil. We also have math.copysign, fabs, and so on. As an exercise, I encourage you to play with a couple of functions in this module. All right, now let's take a look at another useful built-in function in Python. We use the input function to get input from the user. As an argument, we pass a string. This will be a label that will be displayed in the terminal. You will see that in a second. So let's add x colon. Now this function returns a string, so we can store it in this variable. Now let's imagine that y should be x plus 1. Save the changes. Now don't run this program using the Code Runner extension, because Code Runner by default runs your program in the output window, which is read only. So you won't be able to enter a value. So open up the terminal using Control and backspace. Once again, if you're on Windows, type Python. If you're on Mac or Linux, type Python 3 and then app.py. So here's our label. Let's enter a value like 1. We got an error. Type error. What is going on here? Well, when we receive input from the user, this input always comes as a string. So this expression at runtime will look like this. String 1 plus 1. Note that the number 1 is different from string 1 because these are two different types. Now, when Python sees this expression, it doesn't know what to do, because two objects can be concatenated if they are of the same type. So here we need to convert this string 1 to a number. In Python, we have a few built-in functions for type conversion. We have int for converting a number to an integer. We have float. We have bool and stir or string. Now, in this case, we don't need to convert x to a string because x is already a string. If you don't believe me, let me show you. So I'm going to comment out these few lines. Now, let's print type of x. So type is another built-in function. We pass an object as an argument and it returns its type. Also, I'm going to comment out this line because that's the bad boy. We don't want to execute this. Save the changes. Back in the terminal. Let's run this program one more time. Enter 1. Look, this is what the type function returns. Now don't worry about the class. We'll talk about classes later in the course. So the type of x is a stir or string. So let's delete this line. To fix this problem, we need to convert x to an integer, and then we can print both x and y using a formatted string. Remember? So we add an f, quotes. Now here we add a label like x. Then we'll add a field. So here we want to print the value of x variable. After that, we add some more text. And finally, we want to print the value of y. Let's run this program one more time. So here in the terminal, let's enter 1. And here's the result. X is 1 and y is 2. Beautiful. Now, all these built-in functions are self-explanatory. The only tricky one is bool. Because in Python, we have this concept of truthy and falsy values. These are values that are not exactly a Boolean true or false, but they can be interpreted as a Boolean true or false. So here are the falsy values in Python. Empty strings are considered falsy, so they're interpreted as a Boolean false. Number 0 is also falsy. We have an object called none, which represents the absence of a value. We'll look at this later in the course. So whenever we use these values in a Boolean context, we'll get false. Anything else will be true. Let me show you a few examples. So in this interactive shell in Python, let's convert number 0 to bool. That's falsy, so we get false. What about bool of 1? We get true. If we pass a negative number, we'll also get true. If we pass a number larger than 1, like 5, we still get true. So we only get false when we try to convert 0 to a Boolean. Now with strings, I told you that an empty string is falsy. So here we'll get false. Anything else is true. So even if I have a string that is false, we'll get true. Because this is not an empty string, it's a string with a few characters. That's why it's evaluated as true. All right, once again, it's time for another quiz. Let's see if you have been really paying attention to this tutorial. So here's the first question. What are the built-in primitive types in Python? We have strings, numbers, and booleans. Numbers can be integers, floats, or complex numbers. Here's the second question. We have this variable fruit set to apple. What do you think we will see on the terminal when we print fruit of 1? Well, using square brackets, we can access individual characters. The index of the first character is 0, so this expression returns the second character, which is p. What if we add a colon and -1 here? Well, using the syntax, we can slice a string. Our start index is 1, and our end index is -1, which refers to the first character from the end of the string. Now, when slicing a string, the character at the end index, or -1, is not included. So with this expression, we'll get all the characters starting from the second character, which is p, all the way until we get to e. So the result of this expression is ppl. Here's another question. What is the result of this expression? Well, this is what we call the modulus operator, and it returns the remainder of a division, which is in this case 1. And finally, the last question. What do you think we will see when we print bool of false? Well, earlier I told you about falsy values in Python. So number 0, an empty string, and the non-object, these are all falsy values. Anything that is not falsy is considered truthy. Here we have a string that has 5 characters. It doesn't matter what those characters are. This is not an empty string. So it's not falsy, it's truthy. So when we convert it using the bool function, we'll get the Boolean true. And this brings us to the end of this section. In the next section, you're going to learn the fundamentals of computer programming. I hope you have enjoyed this section, and thank you for watching. We're going to start this section by exploring comparison operators. We use comparison operators to compare values. Here are a few examples. So 10 is greater than 3. We get true. So what we have here is a Boolean expression. Because when this expression is evaluated, we'll get a Boolean value that is true or false. Here's another example. 10 is greater than or equal to 3. Once again, we get true. We also have less than, so 10 is less than 20. We have less than or equal to. Here's the equality operator, so 10 is equal to 10. What about this expression? What do you think we're going to get? We get false. Because these values have different types and they're stored differently in the computer's memory. And finally, we have the not equal operator. So now with this expression, we should get true. Beautiful. We can also use these comparison operators with strings. Let me show you. So we can check to see if bag is greater than apple. We get true because when we sort these two words, bag comes after, so it's considered greater. Now what about this one? Bag equals capital bag. We get false. Here's the reason. Every character you see here has a numeric representation in programming. Let me show you. So we have this built-in function called ord. Don't worry about memorizing this because you're probably never going to use this in the future. But let me show you the numeric representation of the letter B. So that is 98. In contrast, capital B is represented as 66. That is the reason these two strings are not equal. So these are the comparison operators in Python. Next, we'll look at conditional statements. In almost every program, there are times you need to make decisions, and that's when you use an if statement. Here's an example. Let's say we have a variable called temperature. We set it to 35. Now, if temperature is greater than 30, perhaps we want to display a message to the user. So we use an if statement. If, after if, we add a condition, which is basically a Boolean expression, an expression that produces a Boolean value. So if temperature is greater than 30, here we have a Boolean expression. If this expression evaluates to true, the following statements will be executed. Let me show you. Now here's the important part that a lot of beginners miss. When you use an if statement, you should always terminate your statement with a colon. Now let's see what happens when I press enter. Our cursor is indented. So here we have two white spaces. This is very important because using these indentations, Python interpreter will know what statements should be executed if this condition is true. Here we want to print a message like, it's warm. We can print another message as well, drink water. So we can have as many statements as we want here. As long as they are indented, they belong to this if block. Now, when we finish here, we should remove indentation to indicate the end of this if block. So here we can add a print statement with a message like done. This statement will always be executed whether this condition is true or not. Now, note that when I save the changes, this indentation you see here is going to be doubled up. Take a look. Save. There you go. So when we save the changes, AutoPep8 reformats our code and uses 4 white spaces for indentation. So 1, 2, 3, 4. It uses 4 white spaces because that's what PEP8 recommends. All right, now let's run this program. So because temperature is greater than 30, we see the first 2 messages and we see the done message regardless. So if I change the temperature to, let's say 15 and run the program one more time, look, this done message is executed whether our condition is true or not. So pay great attention to these indentations. That's one of the issues I see in beginners code. Let's say they want both these print statements to be executed if the condition is true. Accidentally, they remove the indentation on the 4th line. And that's why their program doesn't work as they expect. So be careful about this. Now, what if we want to have multiple conditions? We use an elif statement. So elif. That is short for else if. Here we can add another condition, another expression. So temperature is greater than 20. Once again, colon, enter. Now by default here, VSCode is using 2 white spaces. So don't worry about this. As soon as you save the changes, those 2 white spaces will be converted to 4 white spaces. So let's print a different message. It's nice. Save the changes. Now look, all these lines are indented consistently. You can have as many elif statements as you want. And optionally, you can also have an else statement. So if none of the previous conditions are true, then what you have in the else block will be executed. Once again, we add the colon, indentation, print. Here we can add a message like it's cold. Save the changes. In this case, temperature is 15. So none of these two conditions will be true, and we will see it's cold. Let's run the program. There you go. In this lecture, I'm going to show you a technique for writing cleaner code. So let's say we're building an application for a university, and we want to check to see if the person who's applying for this university program is eligible or not. So we start by defining a variable called age, set it to 22. Now, if age is greater than or equal to 18, print eligible, remove the indentation, else, print not eligible. Let's run the program, make sure it works, beautiful. Now, there is nothing wrong in this piece of code, but I want to show you a cleaner way to achieve the same result. Instead of having a print statement here, we can define a variable like message and set it to this string. That is the first step. So message equals this string. And then we will print this message. Now, when you have an if-else statement with this structure, where you're basically assigning a value to a variable, you can rewrite this in a simpler way. So this is how it works. All we want to do over these few lines is to assign a value to this message variable, right? So we start with message. We set it to eligible if age is greater than or equal to 18, else we set it to not eligible. This statement is almost like plain English. So what we have on line 7 is exactly equivalent to these 4 lines of code. Delete, save the changes, run the program. You can see this person is eligible. If I change the age to 12 and run the program, we get not eligible. So what we have here is called ternary operator. In Python, we have 3 logical operators, and we use these operators to model more complex conditions. So these operators are and, or, and not. Let's see a real-world example of using these operators. So imagine we're building an application for processing loans. So we need 2 variables. High income, we can set this to true, and good underline credit, we set it to true. Now here's the condition we want to implement. If the applicant has high income and good credit score, then they are eligible for the loan. So if high income and good credit, we add the colon and print eligible. Now note that here I have not compared the value of this variable with true. That is one of the issues I see in a lot of beginners code. This is redundant and unprofessional because high income is a Boolean, so it's either true or false. We don't need to compare true with true. So if this condition is true and this second condition is true, then we will print eligible in the terminal. So save the changes and run the program. Obviously, this person is eligible. However, if one of these conditions is false, we will not see eligible in the terminal. So let's add an else statement here and print not eligible. Run the program. We see not eligible. So this is how the AND operator works. With AND operator, if both conditions are true, the result will be true. In contrast, with the OR operator, as long as at least one of the conditions is true, the result will be true. So if I replace AND with OR here, we should see eligible in the terminal. Let's run it one more time. There you go. So these are the AND and OR operators. Now let's take a look at an example of the NOT operator. So I'm going to define another variable, student, set it to true. Temporarily, I'm going to remove this expression and simplify it We'll come back to this later. So let's say if the person is eligible if they are not a student. The not operator basically inverses the value of a Boolean. So in this case, student is true. When we apply the not operator, the result will be false. So in this case, our condition will be false, and that's why this print statement will not be executed. Let me show you. So save, run the program. They're not eligible. If student was false, when we apply the not operator, we'll get true. So our condition will be true and we'll see eligible. Let's run it one more time. There you go. With these operators, we can model even more complex conditions. Here is an example. A person can be eligible if they have either high income or good credit, and they should not be a student. Let me show you how to implement this condition. So if high income or good credit, we want at least one of these conditions to be true. So we put these in parentheses. We want to separate these from the other condition, which is not a student. Now, the result of this should be true, which means at least one of these conditions should be true. After that, we'll add and not student. And finally, colon. So with these operators, you can model all kinds of real-world scenarios. So here's the example from the last lecture. A person is eligible for a loan if they have high income and good credit and they are not a student. Now, one thing you need to know about these Boolean operators is that they are short circuit. What do I mean by that? Well, when Python interpreter wants to evaluate this expression, it starts from the first argument. If this is true, it continues the evaluation to see if the second argument is also true. So it continues the evaluation all the way to the end of this expression. However, as soon as one of these arguments is false, the evaluation stops. Let me show you what I mean. So if I change high income to false, when Python interpreter sees this expression, it starts here. It knows that high income is false, so it doesn't matter what comes after. The result of this entire expression will always be false because at least one of the arguments or one of the operands is false. This is what we call short circuiting, just like the short circuit concept we have in electronics. So the evaluation stops as soon as one of these arguments evaluates to false. We have the same concept with the OR operator. So if I change these AND operators to OR, let's see what happens. With the OR operator, we know that at least one of the arguments should be true. So the evaluation stops as soon as we find an argument that evaluates to true. In this case, when Python interpreter evaluates this expression, it sees that high income is false, so it continues the evaluation, hoping that the next argument will be true. Here, good credit is true, so evaluation stops, and the result of this entire expression will be true. So in Python, logical operators are short circuit. In this lecture, I'm going to show you how to chain comparison operators. This is a very powerful technique for writing clean code. Here's an example. Let's say we want to implement a rule that says age should be between 18 and 65. Here's how we can implement it. So we define a variable like age, set it to 22. Now, if age is greater than or equal to 18 and age is less than 65, then we print eligible. Now here's a question for you. How do we write this rule in math? We can write it like this. Well, more accurately, we should have an equal sign here. So age should be between 18 and 65. This is how we write this rule in math. Now, I've got some good news for you. We can write the exact same expression in Python. So I'm going to move this up, put an if statement here. Line 4 and line 3 are exactly equivalent. But as you can see, line 4 is cleaner and easier to read. So let's get rid of line 3. This is what we call chaining comparison operators. All right, here's a little quiz for you. I want you to pause the video and think about this quiz for 10 to 20 seconds. What do you think we'll see on the terminal when we run this program? So pause the video, figure out the answer. When you're ready, come back, continue watching. All right, let's see what happens when we run this program. First, we get this if statement. In this case, we're comparing two different objects for equality, and these objects have different types. We have a number compared with a string. So number 10 and string 10 are not equal. That is why A will not be printed on the terminal. So the control moves to the elif part. Here we have two Boolean expressions. Here's the first one. Here's the second one. And they are combined using the logical AND. So if both these expressions are evaluated to true, then this entire expression will be true and we will see B on the terminal. Let's see if both these expressions are evaluated to true. Here's the first part. Bag is greater than apple. That is true because when we sort these words, bag comes after apple. But look at the second part. This expression is evaluated to false because bag is not greater than cat. So when we apply the logical AND between true and false, the result will be false. That is why this statement will not be executed. So the control moves to the else part. And when we run this program, the letter C will be printed on the terminal. There are times that we may want to repeat a task a number of times. For example, let's say we send a message to a user. If that message cannot be delivered, perhaps we want to retry 3 times. Now, for simplicity, let's imagine this print statement is equivalent to sending a message. In a real-world program, to send a message to a user, we have to write 5 to 10 lines of code. Now, if you want to retry 3 times, we don't want to repeat all that code. That is ugly. That's when we use a loop. We use loops to create repetition. So here's how it works. We start with for, number, in. We have a built-in function called range. Now, how many times we want to repeat this task? Let's say 3 times. So we call range and pass 3 as an argument. Now, similar to our if statements, we need to terminate this line with a colon, enter, we get indentation. So in this block, we can write all the statements that should be repeated 3 times. Let's do a print, a message like attempt. Save the changes, run the program. So we have attempt printed 3 times, beautiful. Now, what is this number? Let's take a look. It's a variable of type integer. So let's pass it as the second argument to the print function, number. Run the program. This is what we get, 0, 1, 2. So here we have a for loop. This for loop is executed 3 times. In each iteration, number will have a different value. Initially, it will be 0. In the second iteration, it will be 1. And finally, in the last iteration, it will be 2. Now here we can do something fun. We can add 1 to this, run the program, and now the messages that we print are kind of more meaningful or more user-friendly, like attempting number 1, attempting number 2, and so on. We can take this to the next level. So we can pass another argument. Here I'm going to add an expression. One more time, number plus 1. So we'll get 1, 2, 3. Now I want to put this expression in parentheses. So let's select this, put it in parentheses, and then multiply it by a dot. So here we have a string that is multiplied by a number. The result will be that string repeated that number of times. Let's take a look. So run the program. See, that's pretty cool, isn't it? Now let me show you one more thing before we finish this lecture. As you saw, this range function generates numbers starting from 0 all the way up to this number here, but it doesn't include this number. Here we can pass another argument, say start from 1 and finish before 4. With this change, we don't need to add 1 to number every time? Because in the first iteration, this number variable will be set to 1. So we can simplify our code and make it cleaner. Let's run it one more time. We get the exact same result. We can also pass a third argument as a step. So I'm going to change the second argument to 10 and pass 2 as a step. Look at the result. These are the numbers we get, 1, 3, 5, and so on. So pretty useful. You're going to use this function a lot in real-world applications. Continuing with the example from the last lecture, let's imagine the scenario where after the first attempt, we can successfully send the message. In that case, we want to jump out of this loop. We don't want to repeat this task of sending a message 3 times. Let me show you how to implement this. So in this demo, I'm going to simulate the scenario where we can successfully send a message. So we define a variable successful and set it to true. Now here, after this print statement, we'll have an if statement. If successful, colon, then perhaps we can print successful. Now here we want to jump out of this loop. For that, we use the break statement. Let's run this program and see what happens. So there you go. After the first attempt, we are successful and there are no more attempts. So once again, I want you to pay great attention to the indentation here because that's one of the common issues amongst beginners. So here's our for loop. These 2 lines are indented with 4 spaces and they belong to our for loop. In every iteration, these 2 lines will be executed. Now, when we get to line 4, if this condition is true, then these 2 lines will be executed because both these lines are indented below this if statement. Now, let's take this program to the next level. What if we attempt 3 times and we still cannot send an email? Perhaps we want to display a different message to the user. We say, hey, we tried 3 times, but it didn't work. So I'm going to change successful to false. Now at the end, here we can add an else statement. This is what we call a for else statement. What we put under this else statement will only be executed if this loop completes without an early termination. So if we never break out of this loop, then the else statement will be executed. So here we can print a message like attempted 3 times and failed. So run the program. See what we get. 3 attempts followed by this message, attempted 3 times and failed. In contrast, if we change successful to true, because we terminate this loop using this break statement, what we have in the else block will not be executed. Take a look. Run the program. We have 1 attempt, successful, done. In programming, we have this concept called nested loops. So we can put one loop inside of another loop, and with this, we can get some interesting results. Let me show you. So I'm going to start with this loop for x in range 5, colon. Now, inside of this loop, I'm going to add another loop. So for y in range 3, colon. And then in our second loop, I'm going to add a print statement. Here we can use formatted strings to display coordinates. Remember formatted strings? So we have f followed by quotes. Now here we add parentheses for our coordinates. First, we want to display x and then comma followed by y. Let's run this program and see what happens. There you go. Pretty cool, isn't it? So we get 0 and 0, 0 and 1, 0 and 2. Then we get 1 and 0, 1 and 1, 1 and 2, and so on. Now let me explain how exactly Python interpreter executes this code. So here we have 2 loops. This is what we call the outer loop, and this is the inner loop. So the execution of our program starts here. In the first iteration of this loop, x is 0. Now we get to this statement, which is a child of this for statement, because it's indented 4 times. This statement itself is a loop. So what we have inside of this loop will be executed 3 times. In the first iteration, x is 0 because we're still in the first iteration of the outer loop. And y is also 0 because we're in the first iteration of the inner loop. That is why we get 0 and 0. Now we go to the second iteration of this inner loop. In this iteration, y will be 1, whereas x is still 0. That is why we get 0 and 1. And similarly, in the third iteration of our inner loop, we'll get 0 and 2 in the terminal. Now we're done with the execution of the inner loop, so the control moves back to our outer loop. Here we'll be in the second iteration, so x will be 1, and then we start here again. So we have to execute this inner loop 3 times. In the first iteration, y will be 0 and x is 1. So here we have 1 and 0, then we'll get 1 and 1 and 1 and 2. You got the point. So this is all about nested loops. So you have learned how to use for loops to repeat one or more statements in your programs. Now let's dive deeper and see what this range function returns. So earlier you learned about the built-in type function. With this function, we can get the type of an object. So if I pass 5 here and run this program, this is what we get. So the type of this number or this object is int or integer. Now let's look at the type of the value that we get from the range function. So as an argument, we pass range of a number. Let's run this program. So this range function returns an object of type range. So in Python, we have primitive types like numbers, strings, and booleans, but we also have complex types. Range is an example of one of those complex types. Throughout this course, you're going to learn about a lot of other complex types. Now, what is interesting about this range object is that it's iterable, which means we can iterate over it or use it in a for loop. That is why we can write code like this. So this range function returns a range object, which is iterable, which means we can iterate over it. In each iteration, x will have a different value. Now, range objects are not the only iterable objects in Python. Strings are also iterable. So here we can add a string like Python. Now in each iteration, x will hold one character in this string. Let me show you. So print x, and I'm going to delete these 2 lines here. Let's run this program. So in each iteration, we'll get one character and print it. We have another complex type called list, which we use to store a list of objects. So we add square brackets. This indicates a list. Now we can add a list of numbers or a list of strings, like a list of names. You will learn about lists later in the course. So let's run this one more time. As you can see, we can iterate over lists. In each iteration, we'll get one object in this list. Now later in the course, I will show you how to create your own custom objects that are iterable. For example, you will learn how to write code like this. For item in shopping cart, print item. So shopping cart is going to be a custom object that you will create. It's not going to be an integer or a string or boolean. It's a custom object. It has a different structure. And we'll make it iterable so we can use it in a for loop. And in each iteration, we can get one item in the shopping cart and print it on the terminal. So you have learned that we use for loops to iterate over iterable objects. In Python, we have another kind of loop that is a while loop. And we use that to repeat something as long as a condition is true. Here's an example. So let's define a variable number and set it to 100. Now we use while, and here we add a condition. As long as number is greater than 0, we add a colon. Once again, we have indentation, so we can repeat one or more statements. we can print this number and then we can divide it by half. So number equals number. Use the integer division to divide it by 2. Or we can use the augmented assignment operator to shorten this code, like this. Now let's run this program. So here's what we get. Initially, our number is 100. We divide it by half. We get 50, then 25, and so on. So as you can see, in this example, we are not iterating over an iterable like a range object or a string or a list. We are evaluating a condition and repeating a task. Let me show you a real-world example of a while loop. In this interactive shell, Python is waiting for an input. We can type something like 2 plus 2. It will evaluate it and ask for the next input. We can add another expression like 10 is greater than 2. So these steps will continue until we press Control D. So behind the scene, we have a while loop that continues execution until we press Control D. That is the condition that causes the while loop to terminate. Let me show you how to build something like this in Python. So let's define a variable, command, and set it to an empty string. Now, here we need a while loop. We want this while loop to execute as long as command does not equal to quit. So command does not equal to quit. Colon. In this loop, we want to continuously get input from the user. So we use the built-in input function. We add a label like this, get the result and store it in the command variable. Now at this point, Python interactive shell will evaluate this command. We are not going to do that in this lecture because that's way too complex. For simplicity, we can just echo back what the user entered. So print echo, and as the second argument, we pass this command. So this is our while loop. It will execute until we type quit. Now, as I told you before, don't run this program using the code runner extension because by default, it will run your program in the output window, which is read only. So open up the terminal using Control and backtick and run Python or Python 3 app.py. So here's our command prompt. Let's type 2 plus 2. It echoes back. Let's type 3 times 2. There you go. If we type quit, our program terminates. Now let's try it one more time. What if we type quit in uppercase? The program doesn't terminate because as you learned before, lowercase and uppercase characters have different numeric representations. So quit in lowercase is different from quit in uppercase. Now to solve this problem, an amateur programmer may do something like this. And command does not equal to capital quit. So while command does not equal quit in lowercase and quit in uppercase, continue getting input from the user. Let's run this program in terminal and see what happens. So one more time, Python app.py. We type quit. Beautiful, it works. We type quit in uppercase. That would work too. But what if I type quit with an uppercase Q and lowercase UIT? Our program doesn't terminate. So this is a poor way of checking for the quit command. What is a better way? Let me show you. So we don't need this AND operator here. Instead, because command is a string, we can call the lower method. So whatever the user types in, first we'll convert it to lowercase and then compare it with quit in lowercase. With this change, it doesn't matter how the user types the word quit. We'll always terminate the program. Now, the last thing I want to discuss in this section is the concept of infinite loops. An infinite loop is a loop that runs forever. So if I change this condition to true, because true is always true, this while loop will run forever. So to jump out of this, we need a break statement. So after we get the input from the user, we can get the command, convert it to lowercase, and see if it equals to quit. If that's the case, we want to break. Now, with this change, we no longer need to initialize command to an empty string. Previously, we needed this because we had a while statement like this. While command does not equal quit. So we had to define this command variable, and that's why we have set it to an empty string. Without this line, when Python interpreter tries to execute this code, it doesn't know what command is. So now that we have an infinite loop, we no longer need to define command and set it to an empty string. So in terms of functionality, this program is exactly the same as the program we wrote in the last lecture. Just be aware of these infinite loops. Because they run forever, you should always have a way to jump out of them. Otherwise, your program will run forever. And this can sometimes cause issues because if you're executing operations that consume memory, at some point your program may run out of memory and crash. All right, time for an exercise. I want you to write a program to display the even numbers between 1 to 10. So when you run this program, you should see 2, 4, 6, and 8. And after these, I want you to print this message. We have 4 even numbers. Now here's a quick hint before you get started. You should call the range function with 1 and 10. Do not use the third argument, which is called step. So basically, I want you to iterate over all the numbers between 1 to 10. Check if each number is an even number and then print it on the terminal. So pause the video, spend 2 minutes on this exercise. When you're done, come back, continue watching. So we start with a for loop for number in range 1 to 10, colon. We check to see if the remainder of division of this number by 2 equals 0. So if number modulus 2 equals 0, then we print this number. Now let's run this program. So we get 2, 4, 6, 8. Beautiful. Now to count the even numbers, we need a separate variable. So let's call that count. Initially, we set it to 0. Now in this if block, every time we find an even number, we need to increment count. So we set count plus equals 1. And finally, after our for loop, we can print a formatted string. We have count even numbers. Let's run the program, and here's the result. So that brings us to the end of this section. In the next section, you're going to learn how to create your own functions. I hope you enjoyed this section, and thank you for watching. So far, you have learned how to use some of the built-in functions in Python, such as print, round, and so on. In this section, you're going to learn how to write your own functions. Now, you might ask, but why do we even need to write our own functions? Well, when you build a real program, that program is going to consist hundreds or thousands of lines of code. You shouldn't write all that code in one file like we have done so far. You should break that code into smaller, more maintainable, and potentially more reusable chunks. You refer to these chunks as functions. So let me show you how to create your own custom functions. We start with the def keyword, which is short for define. Next, we need to give our function a name. So let's call this greet. All the best practices you learned about naming your variables also apply to naming your functions. So make sure your function names are meaningful, descriptive, use lowercase letters to name your functions, and an underscore to separate multiple words. Now, after the name, we need to add parentheses. You will see why shortly. And then we'll add a colon. Now, what is going to happen? You know it. We're going to get indentation, which means the following statements will belong to this function. So here I'm going to add 2 statements. Hi there, and welcome aboard. Both these lines belong to this function because they're indented. Now we're done with this function, we need to call it. So we remove the indentation and we add 2 line breaks after this function. This is what PEP 8 recommends to keep our code clean and maintainable. Now, if you forget to add 2 line breaks, don't worry. As soon as you save the changes, AutoPEP 8 will automatically add these line breaks for you. Let me show you. So I'm going to remove these line breaks and call this function greet with parentheses, just like how we call the built-in functions. Now save the changes. There you go. So we get 2 line breaks after our function. Now let's run this program. So we get these 2 messages on the terminal. Now here's a question for you. What is the difference between the greet and print functions? The difference is that this print function takes an input, whereas our greet function doesn't take any inputs. So let me show you how to pass inputs like first name and last name to this function. When defining a function, in between parentheses, we'll list our parameters. So here we add 2 parameters like first underline name and last underline name. Now, when calling this function, we need to supply 2 values for those parameters. We refer to them as arguments. So, Mosh, Hamedani. These are the arguments to the greet function. That's one of the terms that a lot of developers out there don't know. They don't know the difference between parameters and arguments. A parameter is the input that you define for your function, whereas an argument is the actual value for a given parameter. Okay, now let's change line 2. And instead of saying hi there, we can greet a person by their full name. So we can convert this to a formatted string and pass 2 fields here, first name as well as last name. Save the changes, run the program, and this is what we get in terminal. Now this function is more useful. We can reuse it and call it with different arguments. So let's greet John Smith as well. Run the program. So we get hi Mosh Hamedani and hi John Smith. Now note that by default, all the parameters that you define for a function are required. So here our greet function takes 2 parameters. If I exclude one of these arguments and save the changes, you can see we have this red underline. So Pylint is complaining and saying there is no value for argument last name. Also, if we run the program, we get this type error, greet missing 1 required positional argument. So let's put this back. Now later I will show you how to define optional parameters. So this is the simplified version of this greet function we created earlier. Now in programming, we have 2 types of functions. Functions that perform a task and functions that calculate and return a value. Here are some examples. Both the print and greet functions are examples of type 1. They're performing a task, which is printing something on the terminal. In contrast, the round function is an example of a function that calculates and returns a value. So the functions that you create fall into these 2 categories. Now let me show you how to rewrite this greet function, but in the second form. So instead of printing this string on the terminal, we simply return it. Let me show you. So I'm going to delete all this code, define a new function, but call it get underline greeting. We add the name parameter and simply return this formatted string hi name. That's all we have to do. So we use the return statement to return a value from this function. Now we can call this function get underline greeting, pass a name like Mosh. Because it returns a value, we can store that value in a separate variable like message. Now you might be curious, which form of these greeting functions is better? Well, with this first implementation, we are locked to printing something in the terminal. In the future, if we want to write that message in a file or send it in an email, we have to create another function. So we cannot reuse this greet function in other scenarios. In contrast, this second form is not tied to printing something on the terminal. It simply returns a value. Now we get this value and we can do whatever we want with it. We can print it on the terminal, or we can use the built-in open function to write this message to a file. So we can create a file like content.txt, open it for writing. This returns a file object, and then we can call file.write message. Now don't worry about these two lines. Later in the course, I'm going to talk about working with files. But what I want you to take away here is that we have this message variable and we can do whatever we want with it. We can print it on the terminal, write it to a file, send it in an email, and so on. And one more thing before we finish this lecture. So here's our greet function. And as you can see, we're simply printing a string. Now, if we call greet, give it a name, run the program, we get this message, hi Mosh. But what if we put this inside of a call to the print function? Let's see what we get. We get hi Mosh followed by none. What is this? None is the return value of the greet function. So in Python, all functions by default return the none value. None is an object that represents the absence of a value. Later in the course, you're going to learn more about none. What matters now is that all functions return none by default unless you specifically return a value. So here, if we return some string, none will no longer be returned. Now, I just want to clarify something. Earlier, I told you that we have two types of functions in programming, functions that carry out a task or functions that calculate and return a value. So back to the code we previously had. So even though this function returns none by default, it is still classified as a function that carries out a task. Let's create another function. We call it increment. We want to use this function to increment a number by a given value. So here we simply return number plus by. Now we can call this function like this, increment 2 and 1. This returns a value, so we can store it in a variable like result and then print it on the terminal. Let's run the program. We get 3, beautiful. Now we can simplify this code. We have used this result variable only in a single place, that is line 6. So we don't really need it. So on line 6, we can replace result with a call to increment function, like this. So when Python interpreter executes this code, first it will call the increment function. It will get the result and temporarily store it in a variable for us. We don't see that variable. And then it will pass that variable as an argument to the print function. Now, if we run this program, we get the exact same result. Beautiful. Now we can make this code more readable. If someone else looks at line 5, they may not know exactly what these arguments are for. We can use a keyword argument to make this code more readable. So this 1 here is the value of this by parameter. We can prefix it with the name of the parameter like this. Now we can read this code almost like plain English. Increment 2 by 1. So if you're calling a function with multiple arguments and it's not quite clear what these arguments are for, you can make your code more readable by using keyword arguments. So here, by equals 1 is a keyword argument. Earlier, I told you that all the parameters that you define for a function are required by default. In this lecture, I'm going to show you how to make the by parameter optional. So let's say we don't want to explicitly pass by equals 1 every time we want to call this increment function. We want to use this function to increment a value by 1. So we remove the second argument. Now we need to give this parameter a default value. So we set it to 1. Now if we call this function and don't supply the second argument, this default value will be used. Otherwise, the value that we specify here will be used. Let me show you. So we run this program. The result is 3. But if we pass the second argument here, we'll increment 2 by 5, so we will get 7. So you can see it's pretty easy to make a parameter optional. Just be aware that all these optional parameters should come after the required parameters. In other words, I cannot add another required parameter here. Let's call that another. I cannot add that here. If I save the changes, you can see we get a red underline here. So all the optional parameters should come after the required parameters. Now, obviously, in this case, we don't need the second parameter, so let's delete it. There are times that you may want to create a function that takes a variable number of arguments. Here is an example. Let's define this function, multiply, that takes 2 parameters, x and y, and simply returns x times y. Now we can call this function like this. So far, so good. But what if you want to pass 1 or 2 more arguments here? That doesn't work because our multiply function takes only 2 parameters. To solve this problem, we need to replace these 2 parameters with a single parameter. We use a plural name here to indicate that this is a collection of arguments. And then we prefix it with an asterisk. This is the magical part. Let me show you what happens when you use an asterisk here. So temporarily, let's delete this line and simply print numbers. Let's see what we get here. So run the program. We can see all our arguments and they're packed in parentheses. What is this? Well, earlier you learned about lists. I briefly mentioned that you can use square brackets to create a list of objects, like 2, 3, 4, 5. Now later in the course, we have a comprehensive section about lists. So don't worry about the details of lists and how they work. But what I want you to note here is that the only difference between this list and what we have here is in the notation. So we use square brackets to create lists and parentheses to create tuples. Some people call it tuples or tuples. So a tuple is similar to a list in that it's a collection of objects. The difference is that we cannot modify this collection. We cannot add a new object to this tuple. Once again, later in the course, we're going to have a comprehensive section about lists, tuples, and other data structures. What matters now is that these tuples, just like lists, are iterable. So we can iterate over them, which means we can use them in loops. Let me show you. So let's write for number in numbers, colon. Let's just print one number at a time. Actually, we don't need this line, so delete and run the program. So we iterate over this tuple, and in each iteration, we get one number and print it on the terminal. So now with a simple change, we can calculate the product of all these numbers. All we have to do is to define a variable like total. Initially, we set it to 1, and then in each iteration, we get total and multiply it by the current number. Or we can rewrite this statement using an augmented assignment operator. So total times equal number. Line 5 and 4 are exactly identical. So I'm going to use line 5 because it's shorter and cleaner. Delete. And finally, we'll return the total. Now, one of the issues I see often in beginners code is that they don't use this indentation properly. So they put the return statement here, and then they wonder why their function doesn't work properly. If you put the return statement here, it will be part of the for loop. So it will be executed in each iteration. In this case, after the first iteration, because of this return statement, will return from this multiply function. So the total will not be calculated properly. We need to put this at the same level of indentation as other statements in this function. So here we have our for statement. We loop over all the numbers, we calculate the total, and then finally return it. So with this implementation, we can get the result and print it on the terminal. Let's run the program, and you can see The product of these numbers is 120. So in the last lecture, you learned the syntax to pass a variable number of arguments to a function. We have a variation of this syntax with double asterisk, and that's what I'm going to show you in this lecture. So for this demo, let's rename this function to save underline user and rename the argument to user. So let's imagine we're going to use this function to save information about a user. Now, in this function, let's just print this user argument. We're done with our function. Let's call it save underline user. Now, instead of passing arbitrary arguments here, we can pass arbitrary keyword arguments. Remember keyword arguments? So we have name equals value. So here we can add multiple keyword arguments like ID equals 1, name equals John, age equals 22, and so on. So we are passing 3 keyword arguments to this function. Now let's run this program. This is what we get. Look at the syntax. We have these curly braces, and in between them, we have multiple key value pairs. So key colon value, comma, here's another key value pair, and here's the last one. This object you see here is called a dictionary. It's another complex type or a data structure in Python, and I'm going to talk about that in detail later in the course. For now, all I want you to take away is that when we use double asterisk here, we can pass multiple key value pairs or multiple keyword arguments to a function, and Python will automatically package them into a dictionary. So this user object here is a dictionary. Now using the bracket notation, we can get the value of various keys in this dictionary. So we can print user, square brackets, we pass a string, and this is the name of our key, like ID. Let's run the program. We get 1, or we can access the value of name key, run the program. So name is John. So this is how dictionaries work. In programming, we have a very important concept called scope, which refers to the region of the code where a variable is defined. So in this example, we have this message variable. The scope of this variable is the greet function. It only exists inside of this function. So if we go outside of this function and try to print message, see what happens. As soon as I save the changes, we get this red underline, undefined variable message. And if we run our program, we get this name error, name message is not defined. The same rule applies to the parameters of our functions. So if we add a name parameter here and then try to print it outside of the greet function, we get the same error. So the scope of the name and message variables are the greet function, and we refer to these variables as local variables in this function. They're local in this function, which means they don't exist anywhere else. And that means we can have another function, let's say send email, with a parameter with the same name. Here we can have a message variable, but this message variable is completely different from the message variable we have in the greet function. And of course, the same rule applies to the name parameters in these functions. They're completely separate. These local variables have a short lifetime. So when we call, let's say, the greet function and pass a name, Python interpreter will allocate some memory and have the name and message variables reference those memory locations. When we finish executing the greet function, because these variables are not referenced or used anywhere else, eventually they get garbage collected, which means Python interpreter will release the memory that allocated for these variables. So these are the local variables. In contrast to local variables, we have global variables. So if we move this message variable outside of the greet function, now it's a global variable, which means it's accessible anywhere in this file. So the scope of this variable is this file. We can use it anywhere in this file, in any functions or outside of a function. Now, for this reason, global variables stay in memory for a longer period of time until they are garbage collected, and you should not use them that often. In fact, global variables are really evil. So, as a best practice, create functions with parameters and local variables. Now, what if here in the greet function, we set message to, let's say, B. Now, let's delete this second function. We don't really need it for now. So we call the greet function. In this function, we assign a new value to the message variable. Now let's print this message and see what we get. What do you think we're going to get? Well, let's take a look. We get A. But didn't we change the value of message variable to B? Not really. Because by default, Python interpreter treats this message variable as a local variable in the greet function, even though it has the same name as the global variable that we have on line 1. So these two variables are separate. Now, I have seen some tutorials or even books teaching you bad practices. For example, they show you how to modify the value of this global message variable inside of a function. Let me show you how to do that. But remember, this is a bad practice and you should avoid it at all times. I will explain the reason in a second. So these tutorials or books teach you to use the global keyword here and reference the message variable. When Python interpreter sees this line, it will realize that in this function, we want to use the global message variable. So it will not define a local variable in this function. Now with this change, if we run our program, you can see we get B on the terminal because in this function, we are modifying the value of the global message variable. Why is this bad? Because it is possible that you might have multiple functions that rely on the value of this global variable. If you accidentally or deliberately change the value of this global variable in one function, this might have a side effect in other functions. Those functions may not behave properly. And this way we can create a bug in our program. So, global variables have always been bad. This is not a Python thing. This is a discussion that's been going on for decades. Avoid them as much as you can. Or if there are situations that you really need to define a variable globally in a file, that's okay, but do not modify it in a function as you see here. This is a really bad practice. So, that's all about local and global variables. In this lecture, I'm going to show you how to find and fix bugs in your programs. So here's the multiply function we wrote earlier. Let's add a couple of statements after this function. So print start, and then we'll call the multiply function, give it 3 arguments, 1, 2, and 3. So the result should be 6. And here we print the result on the terminal. Now to create a bug in this program, I'm going to deliberately indent this return statement. So now when we run this program, instead of 6, we get 1. So we're going to use a technique called debugging to find and fix this bug. All right, first we need to open the debugging panel. The first time you want to use debugging in a Python project, you need to click this icon. This will generate a new file called launch.json. In this file, we have a bunch of debugging configuration. You never have to touch any of this, so don't worry about it. Close it. You can see this file is placed inside of this VSCode folder. It's right here, launch.json. Now, when we have this file, we can go to the debugging panel, and from this list, we can select a debugging configuration. Some of these configurations are useful for more complex applications. For example, we use Python Django to debug a web application built with Python. For this course, we're going to use Python current file with integrated terminal. So select this. Now to start debugging, first we need to add a breakpoint on one of these statements. So I'm going to put the cursor on line 8 and insert a breakpoint by pressing F9. So this is our breakpoint. We can press F9 one more time to remove it. If you're on a Mac keyboard, you should press the function key, which is on the bottom left corner of your keyboard, and then press F9. So here we have a breakpoint. Now we can press F5 to run the application up to this point. So F5. So this automatically opens the integrated terminal here. Don't worry about this. I'm going to close it. So you can see our program is running up to this point. This line is highlighted. Now we can execute this program line by line and see exactly what happens at runtime. So to execute one statement at a time, press F10. Okay, we are done. Now we are on line 9. However, on line 9, we're calling the multiply function. If we press F10 again, the execution stops. So we couldn't figure out why we got 1 as the result of multiplying these numbers. So let's start debugging one more time. We press F5. So once again, we are on line 8. Let's step over this line with F10. Now this time, we want to step into this multiply function so we see exactly what is going on here. So instead of F10, press F11. Now we are on line 2. So if you're calling a function that you have defined, you can step into that function using F11. Now here we are in the multiply function. On the left side, inside the variables panel, you can see all the variables that are meaningful in this function. So under locals, we have numbers. So this is our numbers argument. You can see this is set to a tuple with 3 numbers, 1, 2, 3, right? Now our total variable is not in this list because it's not defined yet. The moment we step over this line with F10, total comes to existence, and you can see initially it's set to 1. Now we are at the beginning of our for loop. Let's press F10 one more time. Here we are. We're going to multiply total by number, so let's step over this line as well. Now at this point we have a new variable called number. That is our loop variable. Initially it's set to 1. Now here we are on line 5. If we press F10, we can see we jump out of this function. So our loop did not execute to completion. And that is the reason our program has a bug. So to fix this, I'm going to stop the debugger with Shift and F5. Now, back here, let's remove the indentation, save the changes, run the program in debug mode one more time. So we press F5. Here we are. Let's step over this with F10. Now step into this with F11 and step over these lines with F10 a few more times. So F10, one more time. Total is set. Now we are in the second iteration. Let's press F10 one more time. In this iteration, you can see number is set to 2. Our total is still 1. So let's step over this line as well. Now total is updated to 2. Here we are at the beginning of the third iteration. Let's step over this line. In this iteration, number is 3. So after we execute this line, because total is currently 2, when we multiply it by 3, we'll get 6. So F10, one more time. Now we only have 3 iterations in this loop. So if we press F10 one more time, our loop completes. Now we are ready to return total, which is currently 6. So F10, we are on line 9, and we're done. Now one more tip. In this demo, I put the breakpoint on the first line of the program. You don't always have to do this. For example, here we know that our multiply function has a bug. So instead of putting the breakpoint on line 8, we could put it on line 2. So when we start the program in debug mode with F5, we immediately start in the multiply function. And one more tip before we finish this lecture. If you step into a function and you know that that function works properly, you can immediately step out of that function with Shift and F11. So you don't have to execute the entire function line by line. You can press Shift and F11 to step out of that function. All right, let's finish up this section by looking at a few very useful shortcuts for writing code fast. First, I'm going to show you the shortcuts for Windows users. And in the next lecture, we'll look at the shortcuts for Mac. So if you're a Mac user, feel free to skip this lecture. So here we're on line 9, and my cursor is right at the beginning of the line. Let's say we want to move the cursor to the end of the line. Instead of pressing the right arrow to go all the way to the end, we can simply press the End key, and here's the cursor. Or if you want to move the cursor to the beginning of the line, simply press the Home key. There you go. Similarly, if you want to move the cursor to the beginning of the file, press Ctrl and Home. Here it is, or Ctrl and End to go to the end of the file. Now let's say we want to move this line up. Instead of cutting it from here and then copying it somewhere else, we can simply move it up by pressing Alt and the up or down arrows. Or if you want to move these two lines up and down, simply select them, then hold Alt and then up or down. Very easy. Now, if you want to duplicate a line or multiple lines, simply select them. Now hold down Shift, Alt, and then press the down key. You can duplicate it as many times as you want. There you go. Here's another useful shortcut. If you want to convert this line or maybe these two lines into a comment, simply hold down Ctrl and press slash. Using the same shortcut, you can remove the comment, so you can toggle it. Very easy. And finally, if you want to type the name of a variable or a function like multiply, you don't have to type all characters. Here are a few ways to type this quickly. You can just type the first few characters, and here in the IntelliSense, you can see that. So if you press enter, this is what we call auto-completion. Here's another way. So instead of writing the first few letters, you can just pick any letters in sequence and type them. So I can type MTY, or I can just type MPY or MY. There you go. Here it is. So I hope you enjoyed these shortcuts, and thank you for watching. All right, now let's take a look at the shortcuts for a Mac keyboard. So here we are on line 9, and my cursor is right at the beginning of the line. If you want to move the cursor to the end of the line, instead of using the right arrow to go all the way, simply hold down the Function key and press right. Here it is. Or you can press Function and left to jump to the beginning of the line. Similarly, you can press Function and up to go to the top of the file, or Function and down to jump to the end of the file. Pretty useful. Now let's say you want to move this line up. Instead of cutting it from here and then copying it somewhere else, you can simply move it up by holding down Alt or Option and then pressing the up arrow, or down. Very easy. Or we can select these two lines, hold down the Alt or Option key, move it up or down. Here's another useful shortcut. We can convert these two lines into a comment by pressing Command and slash, and then we can remove the comment using the same shortcut. So we can toggle it. And finally, if you want to type the name of a variable or a function like multiply, you don't have to type all the letters like multiply. That is very slow. You can type the first few letters like mult, and here in the IntelliSense, you can see it's selected, so press enter. Or you can pick any characters in sequence and type them, like MTY, here it is, or we can type MPY or MTP, so you can abbreviate it any way you want. I hope you enjoyed these shortcuts, and thank you for watching. One of the questions that often comes in programming interviews is the FizzBuzz algorithm. You might be surprised that there are a lot of developers out there with even years of experience, but they don't know how to solve this simple programming problem. That's why I decided to include this in my course. So let's see how this algorithm works, and then you can spend 10 to 15 minutes on this exercise on your own. So here we have a function, FizzBuzz, that takes an input, and depending on the input we give it, it returns different results. Here are the rules. If the input that we give it is divisible by 3, it will return the string fizz. Let me show you. So we run this program, we get fizz. If the input is divisible by 5, it will return buzz. Take a look. Here's buzz. Now the third rule. If the input is divisible by both 3 and 5, it will return fizz buzz. So let's pass 15 here. We'll get fizzbuzz. For any other numbers, it will return the same input. So if I pass 7, it's not divisible by 3 or 5, it will return 7 itself. So spend 10 to 15 minutes on this exercise. You will see my solution next. All right, let's see how we can solve this problem. So we get the input and check to see if input is divisible by 3. Then we can set a variable like result to fizz. Now let me temporarily simplify these rules because I want to show you a really cool technique. So let's imagine if the input is divisible by 3, we'll return fizz. Otherwise, we'll return buzz. So else colon, we set the result to buzz, and finally we'll return this result variable. This is one way to implement these rules, but it's not the best way. There is a better and cleaner way. Let me show you. So instead of defining this result variable and then returning it, we can simply return this string here and also here, and then we can get rid of line 6. So we remove one unnecessary line of code. This was one technique. The other technique I want to show you is when you have an if statement and in your if block, you're returning a value, you don't really need an else clause. Because if this condition is evaluated to false, the control moves to the else clause, and all we are doing here is returning a different value. So this is the only possible outcome. So here we can remove this else clause and simply return buzz. So with this technique, I removed an unnecessary indentation as well. I've made our code more linear, okay? Now, let's go back to our original algorithm. So if the input is divisible by 3, we'll return fizz. Now we check to see if the input is divisible by 5, we'll return buzz. So here, we don't really need an elif, because if this condition is false, we'll get here anyway. So we can check if input is divisible by 5, we will return buzz. Once again, if this condition is false, the control moves here. Now we check to see if the input is divisible by 3 and it is also divisible by 5, then we will return fizz buzz. Now, this expression is a little bit long. I would prefer to make it more readable by putting parentheses around the first and second parts, like this. That is cleaner. Now, if this condition is also false, the control moves here. That means our number is not divisible by 3 or 5, so we should simply return the same input. Once again, we don't need an else or another if. We simply return the input. Now let's run this program and see if it's working properly or not. So we call our function with 3, and we get fizz, beautiful. Let's call it with 5. We get buzz, perfect. What if we call it with 15? We should get fizz buzz. However, we get fizz. What is going on here? The reason this happened was because when we pass 15 here, line 2 is executed. Obviously, 15 is divisible by 3, so that is why we immediately return fizz. To solve this problem, we need to move this condition, which is more specific, to the top. So I've selected these two lines using Alt and up. I move these lines up, beautiful. All right, now let's run the program one more time. So we get fizz buzz. Once again, let's test it with 3. Now we get fizz. Let's test it with 5. When writing functions, don't assume that your function is working. Make sure to test it with all different kinds of values. Let's test it with 5. We get buzz, beautiful. What if we pass 7, which is not divisible by 3 or 5? We get 7, beautiful. So what you see here is the simplest and most elegant implementation of the fizzbuzz algorithm. And that brings us to the end of this section. In the next lecture, we're going to explore data structures in Python. You're going to learn about lists, tuples, sets, and dictionaries. I hope you enjoyed this section, and thank you for watching. You made it this far, and that makes me think that you're really enthusiastic about learning Python. So I highly encourage you to enroll in my complete Python course, where we go way beyond this crash course. You will learn how to use Python in real-world scenarios, such as data analysis and visualization, automating repetitive, boring tasks that involve working with files and folders, spreadsheets, PDFs, data compression, sending emails, web crawling, consuming APIs, and much more. This course comes with a 30-day, no questions asked, money-back guarantee and a certificate of completion. If you're interested, click the link below this video to access the course. Once again, thank you for watching. Please support me by liking and sharing this video, and also subscribe to my channel to get free new videos every week. Thank you and have a great day.